In the last lecture, we made a bridge from a wall by using vector-based timeline. You guessed it. It's certainly not the only way to do it. In this lecture, I will teach you how to use linear interpolation through a float timeline. The goal is the same, but methods to achieve it differ. However, you'll have a choice. Who knows? Which method will you fancy the most? Let's return to our wall to bridge blueprint. Now, let's make some space for another timeline. Okay, right-click somewhere in the empty space and search for timeline. Add it to the graph. Let's call this timeline Tilt the Bridge 2. Now double-click on this newly created timeline to open it. Here we need to add a new float track. Do it with me. Let's name this track Tilt the Bridge Float. Okay, now right-click somewhere on the timeline. Select Add Key option. Good. This key will be the starting point of our timeline. Let's make its time and value 0. We also need an endpoint key for this timeline, but first, let's make the length on the timeline shorter. I think 2.5 was good length. Now right-click somewhere on the timeline, and then click on Add Key. Set its time to 2.5. Its value needs to be 1. Soon you'll understand why I'm doing this. Okay, this is all we needed to do in this timeline. Let's return to the event graph. So our goal is to tilt the wall until it becomes a bridge for our player character. We already have this set world rotation node with its target wall. We can copy and paste it nearby. In the last lecture, we split these struct pins. Now we can recombine them by right-clicking somewhere in this area and choosing Recombine Struct Pin. Great. Now instead of 3 axes, we only have a single rotator input pin. We can drag from this pin and search for lerp rotator. Lerp means linear interpolate. Okay, let's hook everything up. The update execution pin of the timeline goes into execution input of the set world rotation node. The tilt the bridge float output pin of the timeline goes into alpha of the linear interpolation node. Take a look at these A and B pins. The A pin should hold a value of the starting point of whatever we want to rotate. Let's return to the level viewport and see what values correspond to the starting point of our blueprint. Okay, so the X value is 0. The Y value is also 0. The Z value is 90 degrees. These are the values we need to write in the A pin of our linear interpolation node. Let's do it now. Please return to the wall to bridge blueprint. Let's input the values. The X and the Y axis should remain 0, while Z axis should have a value of 90. Awesome. We have a starting point. Now we need to find out what should be the ending point of the linear interpolation. Let's again return to the level viewport. I will tilt the bridge the way I want it to become once the player character overlaps the hidden trigger. I'm doing this only to get the values. Okay, nothing changed in the y and z axis. However, the x-axis became negative 89.9. I think we can safely round it to 90 degrees in the B property of our interpolation node. Since I tilted the wall only to get its value, we can return it now to its initial position. Okay, let's return to our blueprint. Now we need to fill in the values of B properties. All we have to do is to set values of x and z axis here. X has to be negative 90, while the z value needs to be positive 90. Everything should work now. But I don't want to continue until I'm sure that you properly understand how this alpha value works. Well, alpha value starts at 0 and ends at 1. So, at 0, it should use values of the pin A. At 1, it should use the values of pin B. In our case, the timeline we created controls the value of alpha. Let's quickly open the timeline now. Take a closer look. This keyframe is at time 0, and its value is also 0. This means that at this point our linear interpolation will output the value of the pin A. The second keyframe is set at time 2.5 and its value is 1. This means that the value of the tilt the bridge float will turn from 0 to 1 in 2.5 seconds. However, the value changes gradually, which means that transition from point A to point B will be smooth. We still need to hook up everything in the event graph, so let's return to it. As you can see, once the overlap of our character with the invisible trigger takes place, this node will fire. But it will fire our old timeline that used a vector as its output. This time we want to run the second timeline that we just created. It's very easy to change the flow of the logic here. All we need to do is to hook up our custom event, make it a bridge with the second timeline. I will hold Alt key on my keyboard and click here to remove this wire. And now I will connect this make it a bridge node with the second timeline. That's it. All we need to do now is compile the blueprint and test it out in the level viewport. Now would you look at that? Everything works just the way we like it. I hope everything in this lecture was clear. Linear interpolation nodes can be used in many different case scenarios. Please don't continue to the next lecture until you are able to build the same logic without referring to this lecture. Try to do it on your own. If you feel that you haven't grasped everything, please don't hesitate to contact me through the QA section of this course. I'll do my best to explain further. Otherwise, this is it for this lecture. Thanks for watching, and I will see you in the next one.